lovely viewers, I welcome you back to this class. Today is going to be problems on bearings and distances. Okay, in my last video I made mention of compass bearing and three-figure bearing, and we were able to state some example on how to convert from compass bearing to three-figure bearing and three-figure bearing to a compass bearing. Now let's get started with these problems. A village Y is 15 kilometers from a point X on a bearing of 0.25 degrees. Now look at this bearing very well. It is simply a three-figure bearing. Now the first thing you do here, bring out your 4 cardinal points here, just like this, and make it big. Okay, X on a bearing of 0.25 degrees. Now in three-figure bearing, we mostly start from the north. You start from the north, then towards each direction. Now from here to here, this point here is simply from 0 to 90. So, and this is 0.25. That means it falls within this range. We move this way. Then we put another cardinal point here. So this is 0.25 degrees, and the distance is simply what? 15 kilometers. So which point is that? A village Y from X. Okay. Now another village Z is 20 kilometers from X. So another village is coming from X again. Okay, on a bearing of 115 degrees. So this one is more than 90, so it falls between 90 and 180, which is this point here. So 115, we go this way. But let's look at the distance. The distance is simply 20 kilometers, so that means it has to be longer than this 15. So we extend. You put another cardinal point. You can see that this point is actually longer than this. Then we merge this all together like that. Okay, this is point Z. Now, don't forget the bearing of this one is simply what? 115 degrees. Okay, so if from here, from this point to this point, don't forget it's from 90, it's 90. So if from here to here is now 25, that will be 90 minus 25, and that will give us what? 65 degrees. Now, from this point, the whole of this point to here is 180. Then from here to here is simply what? 115. That will be 180 minus 115. That's up to what? 65 degrees. So look at this point here. They are said to be perpendicular to each other. So if this is 65, and equal angle, they are simply what? 90. So 90 minus 65 is simply what? 25. That means the whole of this angle here is simply what? 90 degrees. Now, under cosine rule and sine, we can label this triangle in another way, a side in another way. This one represents angle X. So this will be small letter X, that's opposite it. Capital letter Y, small letter Y. Capital letter Z, small letter Z. So in this case now, since we are given two distance, this is 20 kilometers from the question. Since we are given two distance, we are looking for one side. Then we are given a just single angle. We will simply use cosine rule. And cosine rule of this simply means x squared equals to y squared plus z squared minus 2yz times cos what? X. So by replacing all these parameters we are going to have we have x squared equals to our y is simply what? 20. That's 20 squared plus, and our z is simply what? 15 squared minus 2 times 20 times 15 times cos what? 90. So this will be x squared equals to 400 plus 225. Then cos 90 is simply 0 in calculator. So when you estimate all this now, this one nullifies to what? To 0. So we simply have this. So that will be x squared equals to what? 625. So look for the square root of 625, and that simply gives you what? 25 kilometers. So our answer is 25 kilometers. So we have done justice to the first question. That's NECO question 2006 question 15. Now let's get started with the second aspect of it. Okay. Now I'm free to rub off. Okay, let me rub off this part. Okay. The second question. Solution. Two cyclists A and B leave a town C at the same time. Cyclist A speeds at the rate of 5 km per hour on a bearing of 0.49 degrees. Now this also what? Three-figure bearing. So the same thing, simply have our cardinal points like this. Two cyclists A and B leave a town C at the same time. Cyclist A speed at the rate of 5 km per hour on a bearing of 0.49. You can see 0.49. So it's also fall within this range. 90. So we move like this again. So this is move like this. This is actually a port C, 049 degrees. Okay, and B at the rate of what, 9 kilometer on a bearing of what, 275. Now 275 is more than 90, so we move. So don't forget we are starting from the north. We move 90, we move 180, we move to 70, then we stop at a midpoint of 360. So we move like this because it's not to 360. Now let us look at the distance. This distance is said to be longer than this, so this one still extend further. Let me reduce this one. So let me reduce this. Now we can simply join them. If we join these two together, we are going to have okay. So this is 0.2. This bearing is 275 degrees. So then let's fix out the speed. The speed for the first one is 5 km per hour. 5 km per hour. The second one is simply 9 km per hour. 9 km per hour. Okay. So and this is point C. This is A, and this is what, point B. Now we need to get what we are going to hide inside. This is already inside. 049 is already inside the angle, the triangle. Then we simply get this. Now if this is 363, if this is 275, so and the whole of this place from here to this point is simply 360. So we simply say 360 minus 275, and this is going to give us, that is 85 degrees. So we simply say 85 plus what, 49, and that will give us what, 134 degrees. Okay, but mind you something, when you're dealing with distance, you are not actually considering the speed. The values given to us here was the speed, that's kilometer per hour, so we are not going to use that. We simply use the formula in mathematics that says that speed equals to distance over time, also in physics. Okay, now if we have a speed, we want to get distance of these two, so we can simply say distance equals to what, speed times time. So what's our speed? Speed is simply, for the first one, 5